So in the previous unit, we studied a lot about linear, quadratic, and exponential functions, and we learned a lot about them. We learned about the way that their equations look, their graphs look, and being able to identify them from a table, and extended it into some applications. In this new unit, we're really just going to focus in on quadratic functions. So quadratic functions, those are the ones that when they're graphed look like the shape of a parabola, that U shape. And a quadratic function has as its highest exponent an x squared. So highest exponent is a 2. And what we're going to really focus in on these first couple days is the different forms of a quadratic function. So a quadratic can be in one of three forms. It could be in its standard form, it could be in its factored form, or it could be in what's called vertex form. And each form is really good for something, good for identifying a certain characteristic of the graph. So this unit's really all about the graphs, all about the characteristics of the graphs, and being able to recognize these characteristics in an efficient way by looking at our equations. So in our first couple examples here, it says simplify the following functions, identify the function family, then identify the function form. Well, I just mentioned this is a quadratic functions unit. Each of these are quadratics. That's the function family. It's not linear or exponential. And I can know that this one's a quadratic because the highest degree is a 2. So we know that this is a quadratic. Now this as well is kind of deceiving. This is an x times an x. So notice that there's not an x squared technically, but if we were to do the distribution, which we will shortly, we would notice that it is x squared. So this is a quadratic as well. And then this one as well, notice how this quantity is being squared. Well, when we multiply it all out, it will be a quadratic with the highest degree of a 2. So once again, this is a quadratic. Now function form. We can answer this question here right away. So we should notice, at looking at the first one, there are no sets of parentheses. You just have a 2x squared, a negative 4x, and a negative 30. And when it's in its fully multiplied out form, there's no sets of parentheses. There's nothing you can simplify any further. We call that standard form. Right? Standard form is the form that is, like I said, completely multiplied out. And it goes from highest exponent to lowest. So one way to write out standard form is ax squared plus bx plus c. You may see that at times when we're talking about standard form. The a, b, and c, those are just numbers, the coefficients or the constants. So that's standard. This one right here is in our factored form. So when you have your two sets of parentheses, that's what's called factored. And we're going to do some factoring in these next couple of units as well, but this is in its factored form. And once again, each form is really best for something. We're trying to figure out in this video, what is it best for finding with these quadratic graphs? Because we know what a quadratic looks like, U-shaped parabola, right? And there's characteristics on graphs that we can now identify. And then our last one here, function form, notice how there's a quantity being squared. There's not two sets of parentheses. There's only one set of parentheses being squared. And it's not in its fully multiplied out form here like number 1. So we call this what's called the vertex form. So those are our three, standard, factored, vertex. Just by looking at an equation, we should be able to identify that this is in factored form, or this is standard, or this is vertex. That's kind of like the first target. Like, can you look at it and know what form it is? Those are the three forms we have. Now, what the question also asks us to do is distribute. And notice what happens when we do distribute. There's a lot of ways to do this one, but just do 2 at a time with the multiplication. So I'm just going to multiply these two together and call it 2x minus 10. But then I need to multiply that times this x plus 3. So I'm going to get 2x squared plus 6x minus 10x, and then minus 30. Simplify it all down, 2x squared, and then we have minus 4x minus 30. And what do you notice here? It is the same exact thing as number 1. But the question is, did it look like it? No, it did not. It was kind of disguised. but they're the same exact function when you multiply it all out. So when you multiply it out, it turns it and transforms it into standard form. Ax squared bx plus c. Okay? But it's the same thing, just different format. And then our last one here, let's multiply this out. I'm going to have to expand this, write it out twice, x minus 1 twice, and then do the same thing as the previous problem, multiply 2 together at a time, whichever 2 you want, but I'm just going to do these two and call it 2x minus 2, and then I'm going to multiply that into this x minus 1 that's here. And when you do that, you're going to get 2x squared minus 2x, and then I continue the distribution, minus 2x plus 2, and don't forget about that minus 38 hanging out there. So 2x squared, let's see here, minus 4x, and this is a minus 36. And I believe this was supposed to be the same exact thing. I think I had a typo on this last number right here. So it should have been the same thing as well. If I would have made that instead of a 38, if I would have made that a 32, it would have worked out. But they're really the same exact thing, but different forms. So here's where we get into the characteristics. So there's a lot of different characteristics of graphs. In this unit, we're going to really focus in on 3 of them. We're going to focus in on, for a parabola, the x-intercepts. We know an x-intercept is where the graph crosses the x-axis. The x-axis is a horizontal axis. So where the graph crosses our x-axis. We're also going to focus in on a y-intercept. A y-intercept is where our graph crosses the y-axis or the vertical. So whatever it crosses through, that is the y-intercept. And then the last one is called the vertex. The vertex of a quadratic function is always going to be the peak or the valley, the high point or the low point, the max or the min, you could call it. So those are the 3 we're going to look at. So what we have here is really a table for each one. And what we're going to try to do is recognize the function form, standard, factored, or vertex. And from that form, we are then going to try to find a characteristic on the graph that matches that. Because eventually our goal is to have this all mixed up, to have 10 equations, 10 graphs. And from the function form, be able to match them up appropriately to the truly equivalent graph and truly equivalent equation. So in this first one, function form, let's see, I've got a set of parentheses here, and I've got a square. It's not all multiplied out, and I don't have 2 sets of parentheses, so this one is vertex form. So think about the word vertex form. It's probably going to help us find the vertex. So let's take a look at what happens here. Easiest characteristic to identify is the vertex. But we're trying to find the relationship between the equation and also our graph. So this vertex has the coordinate -4, -2. And look at our equation. +4, -2. Okay, so we can kind of see that relationship, what's happening here. It looks like this one, the x coordinate of the vertex comes from this value right here, but it's the opposite of it. And then the y value of the vertex comes from this one right here, but that one stays the same. So -4, -2, we can see vertex from vertex form just by looking at our equation. And that's going to take some practice, so we got to get comfortable with that. And we're going to learn about transformations of graphs in a couple class periods, and that will really hit home as to why the vertex is located exactly in that location. Okay, the next one, function form, parenthesis, parenthesis, I know that is factored form. So factored form, we want to look at a characteristic of our graph and also our equation to see if there's something that matches. Notice how we saw in our equation here and here found us our vertex. Well, let's kind of try to match something else up here. We already did vertex. We were talking about x-intercepts and y-intercepts. Well, this y-intercept is all the way up at 9. It doesn't look like I'm seeing anything here, but look what's happening here. Look at this x-intercept. there's an x-intercept at -1 and -5. Look at our equation. What do you notice there? We got an x plus 1 and an x plus 5. But our x-intercepts were -1 and -5. So x-intercepts is the easiest characteristic to find from its factored form. And noticing the relationship between our equation right here and the intercepts. Let's real quickly talk about this. Let me write these coordinates out. -5, 0, because they're always coordinates, they're points, and -1, 0. Let's talk about this for a second. An x-intercept, let's write out this coordinate, -1, 0. So when x is -1, it makes the value of the function, the y value, 0. So what we're trying to look and see here is at the x value of -1, does it make the function equal to 0? And let's see why that takes place. If I were to substitute in a -1 right here for x, notice what that would become. Well, that was strange. Let's undo that. And it's not letting me, so it kind of dragged to the wrong spot here. Let's see if it comes back up. There we go. Okay. If we were to got to get back to my drawing tools. And I don't think it's letting me do that either. So for some reason that's not working. I'll get back to that in just a second. But if we were to take that x value of -1 and plug it in. If we plug in -1, it's dying on me. If we plug in -1, it would make us get -1 plus 1, which is 0. But then that 0 that's there is being multiplied by 2 and also being multiplied by that second fraction next to it. Well, what is 0 times anything? 0 times anything is going to be 0. So that's how we find that x-intercept. It's whatever makes our factors equal to 0, because then it becomes 0 times something. Okay? And then, oh, there we go. Got it back, guys. Sorry for the delay. I was trying to get the drawing tools back so I could finish the video for you. But it makes it 0 because it becomes 2 times 0 times, who cares what that is, some number, and it's going to be equal to 0. Same thing with -5. -5 would do the same exact thing. It's not liking my tables, guys. Let's continue through this last one, okay? Here's the last part of this video. So if we are going to find our last characteristic, all right, this function form, it's all multiplied out. We call this standard form. Standard form is best for finding one of those three characteristics. Vertex has already been used up, right? So we've already done vertex form. X-intercepts has been used up. And the last thing we have to look at is the y-intercept. So the y-intercept on this one looks like it's at 0, -1. So this is best for y-intercept. Notice how all the text is off slightly at this point from the table getting moved around on me. 0, -1, and look at our equation. -1. Now, it doesn't mean, this is not like in this table, guys. It doesn't mean that that is just the rule we're going to learn. Oh, it's always the last number. The y-intercept is always the last number. No, you got to understand why it is the last number. So the reason that it's the last number is because of the concept of what a y-intercept actually is. And y-intercepts kind of fall under the idea that if you're finding a y-intercept, that's when x is 0. So if you look at your equation and plug in a value of 0 in for x here and here, 0 squared, 12 times 0, those are both 0. So what's left over when you plug in an x value of 0, you get back a y value of -1. So that's why, yes, it is the last number in standard form. But that's kind of the relationship we're trying to find. So, just to summarize this real quick, vertex form is best for our vertex right here, okay? Factored form I wish it was written in the correct blank here. Factored form is best for, maybe I can drag it. That kind of works a little better. Is best for finding the x-intercepts. And it's because it's the x value that makes the y value 0. It's the x value that makes the function equal to 0. And our standard form is best for finding y-intercepts because a y-intercept is when x is 0. So if you plug in an x value of 0, it just cancels, and it's your last number, -1. So that's what we got to get better at next class period when we practice. Standard, factored, vertex, and we got to find our characteristics, y-intercept, x-intercept, vertex. That's it for today. We'll practice it next class.